All right, question 5, our final question, is probably the simplest possible trigonometric integral you could get. We have just signs, so there's no real decisions to be made, and it's a nice odd power. And so as we discussed in class, the smart thing to do here is to peel off a single iteration of that sign, right? A single factor of sign, so that we can make that into our du. So we go, okay, cool. We want du to equal sine of x. And this is really nice because, right, as long as our sign is odd, we now have an even number of signs over here. And usually we have a bit more work, but this is actually the ideal thing, right? We can now use our Pythag identity, sine squared x plus cosine squared x is equal to 1, to rewrite that sine squared x as 1 minus cosine squared x, which is perfect for our u, which we'd like to be cosine of x. Now, of course, if our u is cosine, our du is actually negative sine, so we'll just throw a negative sign out in front of that. So that's the only thing that makes this trickier. I guess cosine cubed would be an easier version of this because there's no negative sign hanging around to make things worse. All right, so we can now rewrite our integral. We're going to replace that sine squared with a 1 minus cosine squared x from our Pythag identity. Leave that sine x, dx. And now if we go back to our u and du, we've got our u and we have our du. Now, a lot of y'all got really creative and wanted to replace the whole 1 minus cosine squared or something else. We are only going to replace the cosine here. That's kind of the whole point. That's why we let that sine x, that whatever our du is, sort of drive the conversation. Because if I let that lead me, I really can't mess this up too hard. So I can come back here and go, okay, this is 1 minus, well, there's a square on my beautiful u. I can go ahead and do that. And then everything underlined in red was just my du. So I'll go ahead and replace all of that with du. And now we're in power rule land, things that we're good at. We did have some mistakes here in this next step. If we are taking the integral with respect to u, right, our du, when we take the antiderivative here, we end up with a, oh shoot, I forgot my negative sign. It's a negative out in front of all this, right? The sine of x was equal to negative du. There we go. I'm ready now. At least I caught it early. When we take the, but I was thinking about it because a lot of students just went ahead and took the antiderivative of 1 and called it x, not paying attention to the fact that we're doing everything in terms of u right now. So we end up with a negative u plus u to the third over 3 plus c, which gives us our final answer here. We'll plug back in cosine, negative cosine of x plus cosine cubed of x over 3 plus c. And like I said, I think one of the most common things, besides just not knowing where to start, there was a lot of students who sort of got hung up trying to do something else. But the other issue was taking the antiderivative of just 1, not paying attention to the fact that we do have a differential there, that du, telling us that we are going to end up with u and not x in our final answer. So there you go. That was our very straightforward trig integral from quiz 1.